Tim, Melissa, are you guys there?
Yeah, I was saying, who's actually running?
Yep. Yeah, we're here.
Awesome.
I mean, we can kick off. I can't really tell. It looks like there's 5 people in the room. So.
Hi, Alyssa.
There's like
Hey there.
20 people in the room.
Okay. All right. Welcome to Mimi. Oh, Tim, are you sharing? Do you want to advance? So this is the note well. Hopefully you've seen it this week already many times. This governs our session today. So please take note of all of the IETF policies and be kind. Next. All right, you need a note taker for today. Would somebody like to take notes? And please come to the mic and tell us what your name is because I cannot see who's there.
For the folks in the room, we'll hang out until we have a note taker, either here or remote. They don't need to be perfect notes. They just need to capture the rough discussion. Oh, that's.
Not naming names.
It is too early in the morning here for Tim or I to do it like we sometimes do. So it would be gobbledygook if I take
All right,
notes.
I'll do my best. I'm Ori Steele.
Okay, thank you, Ori. Appreciate it.
And I heard Sean say, I'll help, so that's 2.
Oh, great. Thank you, Sean. All right, so here's our agenda for today. We have 2 sessions today with the lunch in between. We're doing our administrivia now. Just wanted to note that we do have this Mimi architecture draft that has expired. So maybe, I don't know if Richard, if we're going to talk about during the protocol session, but we should just figure out what to do about that. Rowan, go ahead.
Hi, I'm Rowan May, pretending to be Richard Barnes, who's currently not here.
Oh,
So
right,
I'm
yeah.
presenting for him today. And unless there's some changes to Mimi architecture, I just repost it at the end of the meeting.
Okay, that sounds good. And thank you for presenting on his behalf. Oh, that means Rowan, you're back to back for the first 3 slots.
And I sent a message that you may not have seen yet, but I proposed for agenda bashing that Conrad go right after Mimi protocol, because I think it'll flow better.
Yeah, I think that's fair. And then probably what we would have in the second session is discovery, for as long as we want to talk about discovery. So unless there's any objections to that, I think we can make that swap and have Conrad go after Rowan.
There's thumbs up in the room.
Okay, great. Then I think we can proceed with Mimi protocol.
I'll just stick that on the floor.
That's yours?
That's fine.
All right.
Hi, I'm Rowan May, pretending to be Richard Barnes. So there have been no changes to Mimi architecture. I'm going to just.
Oh, yeah.
So very briefly, is that working? Is it doing anything?
I can advance you if you give me the button. Who's sharing?
Yeah, is it Tim? Are you sharing? Yeah.
Yes, I am.
Tim, just next slide, please. So Mimi protocol is a client to server to client protocol. The server in the middle is called the hub that is responsible for room policy. Next slide, please. Most anything related to a room goes through the hub. Next slide. The unit of functionality is a room. Room has state. There is various types of authorization policy a list of participants, and then there is MLS state, the corresponding crypto state. So in MLS, this is an MLS group, and that includes the list of clients who are members of the group. Participants can either be active, meaning that they have at least one client, an MLS client, which is in the group, or inactive. Next slide. So here is an example of these 3 different types of state here. Next slide. This is all pretty, we've presented this like four times in a row. So if you don't know about this, feel free to look at the slides, come to me afterwards. All right, MLS has this concept of confirmation. So the crypto in MLS doesn't work if you don't agree on what the state is. Next slide, please. Yeah, let's just go to the next slide. So the architecture draft is there. If you haven't read it, please read it. If you're new to the group, have a look at the slides. If you don't understand something, please come and find any one of the usual suspects and ask us. Okay. Mimi protocol. Next slide, please. Okay. So basically, if you want to, the main operations in the Mimi protocol are that if you want to update the status of the room, you send an update, and that contains an MLS proposal or commit. If you want to send an application message, like a text message, you send a submit to the hub. That might go through your provider first, and then the hub will send that out to everybody else. That's called fan out, and it does that with a notify. Next slide, please. Server-to-server communications are over, notionally in this draft over HTTPS, over mutually authenticated TLS. Next slide, please. All right, now we're getting to the interesting part here. So Mimi uses MLS for 3 things: for protecting application messages, for managing which devices have access to the group, and ensuring agreement on room state. So in order to have agreement on the Mimi specific state, that's really application state. So Richard came up with this idea of the AppSync proposal, which modifies a set of what's in MLS called group context. And so this is state about the, for example, the participation list. So the participation list is a list of users and the role that they have. We had a bunch of discussion in the MLS working group on Monday about what we were going to do with the AppSync proposal. And so there's now actually a proposal. When I say proposal, I mean an MLS proposal type that has been proposed called Group Context Extensions diff, which would be a generic way to update group context extensions, whether they contain MLS critical state or just application state. Now, in the case of generic MLS state, we don't know what effect that might have on the MLS stack and the rest of the MLS protocol. So we need to be a little bit careful there. And so every time you do this, you need to do in MLS what's called an update path. This is undesirable to do if you're just doing something innocuous that doesn't have a big impact on your MLS state. And so it's still an open question whether we want to have a separate proposal type. Well, we could call it AppSync or GC diff light or something like that. But whatever it is, that only accesses application state or only accesses state which is safe to change without an update path. However, there is consensus and agreement that we need to both of these things. We need to be able to do both of these operations. We just haven't had time to figure out exactly what form that will take, but it's going to be a pretty straightforward change to Mimi to make it do what we decide in MLS. And I'm going to say, so one minor update to this slide. So this says we have two types of synchronized state in Mimi. So we have policy and participation list. So I think we're now coming to the point, and when I do the room policy presentation later today, that we're getting a little bit more information about what types of policy we're going to need to define. So we know that we have a participation list, which is a list of users who are participants in the group and what their roles are. The room policy document talks about role or attribute-based access control, where we will have a way to define names of roles and what the capabilities of those roles are. There are other forms of state which are sort of, remain fairly slow moving, wouldn't change very frequently about the room. And then we might have additional state that is more dynamic, like room metadata, where you might have the name of a room or the subject or a mood. So these kinds of things that you see on Discord and IRC, that those things can be in a large group, they can change quite a bit. But the idea here is that we can have different containers for these different types of information. And when one of those containers changes, we can change it and change only that without having to send an update, a very large update with a bunch of other information which has not changed. And that we're only making changes to we're only sending MLS update paths when absolutely necessary. Are there any questions about this? Great. Okay, next slide, please.
Nope.
You have Ecker in the queue.
What's your definition of absolutely necessary?
The reason that GCE the group context extensions proposal requires an update path is that it might change something that requires an update path. So it's sort of a, it is a definition where it cannot be shown that you don't need an update path, therefore send an update path. In the case of AppSync, the application state does not affect, the participant list does not affect the state of the MLS group. And therefore we can say that's safe, you don't require an update path. So if you can confidently say there's no update path needed, then there's no update path needed. Does that make sense?
No. I'm looking for the security rationale.
Mm-hmm.
And that's not a security rationale.
Okay. Well, can you tell me what the security rationale is for example, in a remove requires an update path.
Okay.
So
the
there was an analysis because, sorry, go ahead.
So I mean the yeah, I think there was a rationale, but I mean this is what I'm worried about is this is going to create a hole that is then going to get used in ways that seem to be hard to understand and that seem like they're going to require a new rationale. So I'm trying to understand like what the analysis is going to get us there.
Okay, so I'm going to posit that if the state which is being changed does not affect MLS state, but only affects application state, then it's safe to update without an update path. It doesn't change anything that MLS is doing or not doing. In the case where you have,
so perhaps Cameron will be able to just align this.
I'm sorry, could you repeat that, please, Ecker?
I said, well, I'm going to get off the mic. I see Cameron's in the queue. Perhaps he wants to weigh in on this topic. Right.
Thanks, Ron. Can you talk about changing the mood of the room? What does that mean? How does it get changed?
Sure. Okay. So if I have a room metadata So I think a lot of people are not familiar with the use of the term mood in this context, but it's like, you know, the mood of the room is excited, right? It's so you have a, you know, a Taylor Swift fan group, and there's a concert coming to that area, and so somebody changes the mood to excited, and then somebody posts something negative about Taylor Swift, and then someone changes the mood to, you know, disgusted or whatever, right? This obviously has no impact on the MLS state. It has very little, you know, it doesn't impact the operation of the Mimi protocol itself, but it's a container where you can change information that's going to be rendered, and the way in which it's changed is that you can atomically change just the room metadata, or maybe even just change only one attribute, in this case, the mood of that metadata. I believe you are next.
Next, okay. Conrad Colbrook, Phoenix R&D. Just going on the update path discussion. So I think it really depends on the, as you say, on the state that's being modified, and in most cases it probably doesn't matter. But the rule of thumb is probably if you need, if the change to the state is related to the membership list, and
the MLS membership list.
The MLS membership list, not the participant list. Then if you feel as a person who is, as the application, you need post-compromise security in that regard, then you might want to require an update, but that's really up to the application to decide. We cannot really make that judgment, except in this particular case where we're the application and we are modifying the participant list, and we're saying, okay, we don't need PCS for that.
Yeah. So in the case where you're removing clients, that's clearly a case where you require an update to the, where you require an update path.
Yeah. I think there's not much more to say about this. Yeah.
Jonathan.
So maybe this is me just being insane, I guess. This is binding Mimi directly to crypto properties of MLS. By which I mean, the reason you need this update path is because of properties of MLS. And when we do MLS 2.0, it might need different crypto properties. So maybe we should consider writing Mimi in such a way that it just takes an underlying transport with certain properties, and we could swap it for Mimi for MLS 2.0 in 10 years' time.
Yeah, I think you're misunderstanding the scope here. So the GCE diff extension and the GCE diff proposal type in MLS and the group context extension proposal in MLS, they require an update path. Yeah. So MLS requires that proposal have an update path because it can change things which would require post-compromise secrecy to be updated. Nothing in the Mimi state, changing Mimi state, does not require you to send an update path. The discussion in MLS was whether we want to use one proposal type or two proposal types in order to update MLS state and Mimi state. So whether we want to have one proposal type which can selectively be used with that selectively requires an update path, or two where there's a more explicit notion where one you use when you don't require an update path, as is for application state, or the other one which always does. Does that make sense?
It does, but yeah, I think to my mind at least, if we want to have some hope of like being able to swap out the transport protocol later, or the group agreement protocol, I guess, later, the two makes more sense to me than one.
Got it. Okay. And like, I'll try to remember to, you know, I'm standing up here without, you know, a note-taking device, but I'll try to remember to like pass that on to MLS. But if you want to sort of shoot a message over to MLS or to like, you know, to some of us individually or whatever, please do that so that doesn't get lost. Okay, next slide, please. All right. I think I've already talked about most of these things here, but we have here, there's just sort of a bit of an illustration of a room identifier and then a name of one of the roles, in this case admin, and then some attributes, some capabilities that that admin has, and then an example of a participation list that only has one participant at the moment, which would be Alice, who is an admin. Next slide, please. All right. This is a list of the HTTP endpoints which are currently in the draft. The new ones which have been added are the ones related to consent. You can request and update consent. A query for a user in a target domain by a particular identifier. So if you had, say, the full handle of someone in a particular domain, you could go and query to get the internal identifier that you would use to go and then fetch, do a consent request, and then eventually to request keying material to fetch key packages. Finally, there is a report abuse endpoint, which is not surprisingly used to report alleged abuse, things like spam or harassment. Mark.
Mark Nottingham, broken record. I apologize, I have not been following this work perhaps as closely as I should have, but I will point out, as I have elsewhere, we have an HTTP directorate for reviewing the use of HTTP and IETF protocols. I would strongly suggest you request an early review.
Please stay there. So MNOT pointed out that we should have an early review. We did. We have a directory. So the first endpoint here is a directory. So the endpoints listed here are example names, which would have been discovered via the directory.
I love you.
Thank you very much. That's such a nice thing to hear on this morning. Next slide, please. Okay, so what's changed? Next slide. Okay, these are the PRs that have been merged since the last IETF. Let's see how I'm doing for time here. Okay, so starting from the bottom, so I added a PR for semi-private messaging. This is a way that instead of sending a public message when you send a commit or a proposal, commits and proposals are called handshake messages, by the way. Whenever I send a handshake message, previously this was sent as a public message, and this meant that any additional provider that was in the path could see the commits and proposals and could build up a list of the participants in a group, and therefore could build up a social graph. So using a semi-private message is a new MLS wire format that allows you to send a message that is encrypted to the members of the group and a list of external parties. And in the Mimi case, this list of external parties is only the hub. So the hub gets to see the list of participants and all of the changes, but other providers do not. The next one, the big one, is the abuse reporting mechanism. This also uses something called franking. I'm going to have a couple more slides talking about these. The next two were ways to protect this structure called a group info and the ratchet tree from which also contains important metadata from being viewable by other providers. And the middle one there also sort of as a it is actually it provides this privacy sort of as a consequence of doing something efficiently, so it doesn't send the information that would have been private in the first place. So kind of killing two birds with one stone there. And the last one, Deirdre thankfully added a nice diagram that we could use for the that explained a little bit better how we got a key that we use in the franking mechanism. All right, next slide, please. So going back to IETF 120, we had a discussion where we said there are kind of 4 levels of metadata privacy that we could have. So the first one was clients and any provider that is involved in the room get to see the room policies, the participation lists. They basically get the full metadata of the group. They don't get to see messages, but they get to see metadata. We came to pretty much unanimous, we came to unanimous consensus, I believe, that that was unnecessary oversharing of information. Then we have clients and hubs having being the only ones that could see the metadata. So this is the baseline level, and you know this is basically done. There's some there's some rough edges to file off, but we did a lot of work to make that happen. Third mechanism was that the clients and the hub server have this information, but that when you deal with the hub, that you can use pseudonyms in order to do that. And this would be an opt-in mechanism. This is still a bit work in progress, but we've made a lot of, we have a lot of concrete mechanism, and Conrad is going to discuss several particular proposals for how to do that after I'm done. Finally, we had clients only, and we concluded that that was too much functionality loss. So this is what you guys asked for. This is what we worked on. Next slide, please. Okay. I basically already described semi-private message, so let's go on to the next one. I wanted to take just a quick moment to break down what we did in terms of protecting the group info and the ratchet tree. So one PR was that that when someone who wants to join externally goes to fetch a group info and a ratchet tree, that they provide an ephemeral public key, and the hub encrypts the group info and the ratchet tree with that to send it back, and so that prevents the external joiners provider from being able to see the group context and therefore the list of members. Already we have protection in a welcome that the group info is encrypted to the new joiner inside of a welcome. When sending a commit, I added an option that was inspired by Raphael and Conrad's partial group info struct in one of their drafts, and so this basically provides a way that the hub can say, I'm going to construct the group info and the ratchet tree from the commits and proposals that I see, and the only extra pieces of information required are a set of extensions and a tag. And so those are shared, those are safe to share over Mimi. And with that information, the hub can reconstruct the group info and the ratchet tree. The committer's local provider doesn't see them because they don't see the commits and proposals because they are protected with a semi-private message. Finally, the follower servers, they see the proposals and commits, which are encrypted with a semi-private message, so they can't read them, but they don't see the group info or the ratchet tree, which is sent to the sent during every commit. Because the way fanout works, fanout sends the proposals and commits and application messages, but doesn't send the extra information which was sent to the hub. So I think this sort of nicely wraps a bow around the scope of the information that we're sharing and gives us some nice properties. Next slide, please. Okay, now we next looked at abuse reporting. So I'm not going to go over all of these requirements in great detail because I already did that at not one, not two, but 3 interim meetings. And it was discussed on the list. But basically, we want to make sure that when someone reports a message as abusive, that they have a way to say, yeah, this message was authentically sent by a particular user, and it was received by the hub. So franking is a way to, next slide, please. Franking comes from the Postal Service, the International Postal Service, where you had a way of sort of stamping something and saying this was received by this post office. It stamps the envelope. So the post office doesn't know what was inside, but it can say this was received. This is it went through us. This was how we got it, and so on. So incoming messages are franked. So what that means is the sender creates a unique per message secret. It encodes or per message key. It encodes this key, its identity, and the room URI inside the message. It generates a franking tag covering the message, puts it in its additional associated data, and it sends this to the hub. The hub figures out the context, the sender URI, the room URI, and the timestamp. Now, this part is new. It uses the associated parties draft written by Conrad to come up with a key for the member that is shared between the members and the hub, and it uses this to hash the franking context. Then it generates the actual frank, which is a hash of the tag and the context hash, and it forwards this on to the receiver. The receiver then verifies the tag and the context and that they are correct. If they're not correct, then it throws away the message. So if the sender lies, if the hub or one of the other providers tampers with the message en route, the message doesn't get delivered. John, do you want to ask now, or do you want to wait until the abuse report slide, the next slide? Okay. Next slide, please. So, whoopsie.
Sorry, we have Eckert. Oh, that must have been a mistake.
He's back.
No, but I can wait.
Okay, next slide, please. Yeah, okay. So then to report a message, the report is sent by a receiver to the hub. It contains the decrypted message and the frank, and it says, hey, you got this message, I have a frank that says that you got this message, like, I think this is spam, or I think this is abuse, please go deal with this. Before I talk about the hub-to-hub communication and some other stuff like that, I want to go ahead and take the questions in the queue. Go ahead, John.
Yeah, I'm sorry, John Peterson. I wasn't clear from the previous slide where it is that the message content was actually integrity protected in the set of properties that you outlined. Is that part of the context, or like is
that's part of it's sent as an MLS private message. So the message is encrypted and integrity protected by the sender.
Oh, I just didn't
MLS.
see how that was included in the frank, though. I know that's true, separate than MLS, but like how is that incorporated into the frank?
So the franking tag is a piece of information which is included inside the encrypted message.
Yeah.
And the franking.
So it can't have integrity over the content of the message itself, right?
Right.
So, I mean, this is the point. When you get to this stage, you're saying this message was actually abusive. Like, how does the recipient prove that to somebody if there's no integrity check over the content of the message itself?
It is a little early in the morning for me to reconstruct all this.
I mean,
That's a
I
good
probably just
question.
missed
Thank
it
you.
in your previous slide. I mean, it doesn't
Yeah.
seem like this would be a difficult property to provide, but I just didn't see where the message content was actually in this.
Yeah, so certainly that the intention was to provide that property. I believe it does provide that property. I need to go back and, you know, I may need a moment to reconstruct that state.
Okay.
Uh,
Okay, and there's also like no possible problem with sending the decrypted message to the hub, like along with the Frank, is there, right?
no possible cause for alarm that
Yeah.
somebody could potentially send
I
lots and
know,
lots of
yeah.
decrypted messages.
Doesn't that seem like something to do?
Yeah, you could, but it's coming from a member of the room.
Oh, I
And so
got
the
it.
member of the room
They would
could,
be accountable for it. I know
they
that.
could go and download the entire message
Of
history
course,
and post it on,
Reddit. Yeah,
you know,
no, I got it. Okay.
post it on Twitter if they want. So
Okay. No, I buy that one. Okay.
Ecker.
Yes, this actually goes to John's question, which is previous attempts to this have not worked as well as one had hoped. So I guess I'm a little concerned that we're inventing a new scheme in this that does not seem to have a paper describing why it's safe or proof describing why it's safe.
So this is an adaptation of the Facebook franking scheme.
Right, which is insecure.
Say again?
Which is insecure.
And so there's a paper describing in what way it is secure by
Grubbs. Yes, I'm aware of the context. That's what I'm asking.
Yes. So yeah. So this mechanism was reviewed by several of those authors, and like they gave some helpful suggestions. And one of the changes which was made as a result of that review was using a key that was shared between the hub and the members in order to protect the franking context, to avoid the context from being the sender of the message from being leaked to follower servers.
That's not the concern. That's not my concern. My concern is
I realize that. Yeah. So I apologize that I cannot remember off the top of my head at 10 o'clock.
I'm actually not asking for discussion of the technical details. I'm asking for a process, which is I would like this reviewed. I would like them actually explicitly reviewed in some memorializable way that is not Richard Barnes talk to Paul Grubbs and shove this in the document.
Okay. What would you suggest?
I'd like CFRG to look at it.
Sorry, could you say that again? That was a little
fast. I would
fast.
like CFRG to look at it.
Okay. Fair enough. I think that's an eminently sensible request. Okay, I do want to highlight one important thing here, which is that using this franking mechanism introduces a requirement that is new, which is right now the hub accepted time in the previous version of the draft, the hub accepted time was sent from the hub to each of the follower providers. And then it was sort of recommended that that time be then provided to the clients. This introduces the requirement that that time needs to be provided to the clients. Otherwise, the clients won't be able to construct the franking context. And if that time is modified, then the message will be rejected because the context will not match. Anyone? Bueller? No, okay. This didn't seem like, this is a change from what we had discussed going way back to Prague when we decided on using a hub accepted time between the providers, but not to the clients. But I think this is the sort of least bad option here. Okay. Now, before we go on to the next slide, I want to bring to your attention issue number 89. Malicious follower can maul server frank. So this was brought up by Julia Len, who was one of the later reviewers of the franking mechanism. So the problem here is that with the mechanism as it is in the draft now, a follower server could effectively destroy the server frank, or modify the server frank, and because the server frank is an HMAC, there would be no way for the client to detect that it was modified. And then when the client wanted to report abuse, that would be, the hub would say, I don't know what you're talking about. I didn't frank this. So this would be the attack here would be where the follower server wanted to prevent one of its users from being able to report a message as abusive. So I believe that the sort of most straightforward way to address this problem would be to have the hub sign the frank and the hub accepted time. Of course, one of the whole reasons why Facebook chose to use an HMAC was because of the performance implications of an HMAC being much faster than a signature. So there's an issue there. If people want to discuss that issue, we can discuss it. If you want to discuss it, go read the issue and comment on the issue. That's great. I would love for us to discuss this in an interim after everybody's had a chance to go and look at that, and to go and look at the numerous documents describing the franking mechanism. Conrad.
Just a quick thought. Since we have already key material shared between the hub and the clients, but not the other servers, couldn't we just MAC it using one of those keys? And that'd be efficient, and the follower server can't reproduce.
If you do what, so Conrad said, what if we just MAC it with a key which is shared with all those folks? Then anyone any member would be able to impersonate the frank, would be able to say, I'm the hub and I signed this.
True, but they could do that right now, right?
No, they can't do that right now under.
Well, I mean, you do both things, right? You have the MAC from that you have right now, and then additionally you have a MAC over the whole thing.
Yeah. Okay.
That would at least exclude the follower servers.
Okay. So it sounds like we have a concrete proposal here, which we can work on later. This is a fairly late, by the way, this is a fairly late feedback that I got here. So.
John Peterson again, just to tag team on that a little bit. I mean, obviously, I understand there was some kind of Mimi identity draft that existed at one point, and it would be great if this thing actually incorporated some provable concept of identity, especially for cross-service identifiers that people might want to use and things like that. But if that was incorporated into this, that would also probably eliminate some of the possibilities about people impersonating other people.
Yeah. So.
Rather than generating a new key for this purpose.
So
right?
so just to be clear here, John. So what we're talking about is we're not ever worried about a credential, because we have MLS credentials, and the MLS credentials we expect will be, we'll have cryptographic proof of specific users that are members of the Mimi room. This is about keys which are for the hub, and so those things were not originally discussed in Mimi identity.
So the reason why I bring up identity, of course, is because this is an abuse redressment mechanism, right? In the sense of somebody should be holding the bag at the end of the day, and like that person should be identifiable. And
yes.
like that. That's why I'm saying I'm
right.
kind
so
of
those
identity isn't in the discussion of this, but
well, because the user that's being reported, there is a credential associated with that user.
Yeah.
And so that is
it's a traceback mechanism. I get that.
Yeah. So okay. I think we got you covered, is what I'm saying. But let's, devil is in the details, and we haven't done identity stuff yet. Okay, moving on. Next slide, please. How are we doing for time?
Alyssa says we're okay in the chat.
Okay. So this was kind of a big lift, right? But you guys asked for it. We added it. What do y'all think? Do you like it? Is this in the right direction? Is it like, oh, wow, that's a lot more work than I thought it would be. Could we do something else? Can we make it optional? Do we have any feedback in general on, the fact that we tried to address these problems We've come up with some plausible mechanisms that still need some review by CFRG, but otherwise, you know, pass a basic sniff test.
Yeah, Rafael Roberts, Phoenix R&D. So I obviously like it. That shouldn't come as a surprise. I think, I want to give a little more context. I think it strikes exactly the right balance in the sense that the mechanisms that are being proposed are not super complicated and they're not super heavy on the computational side either, especially the semi-private message thing, associated parties, etc. So it's neither rocket science nor is it going to drain your battery or any of that. So in that sense, I'm very happy with the outcome of that. The pseudonymous approach that Conrad is going to present in a bit, there's still a few rough edges, but there's a good starting point that needs some polishing. But it's not like we have to invent something entirely new. There's quite a bit of substance there.
Okay.
Yeah, just want to add that context. Thanks.
So yeah, I'm particularly interested in getting feedback from implementers or potential implementers. Next slide, please. Okay. Yeah, so this is, basically this is what we did. We did this level of metadata privacy. It provides, I think, an admirable baseline level of metadata privacy for a federated protocol. It does rely on 2 new MLS extensions. It adds non-trivial complexity. Could result in it taking a little longer for implementations to come. So far, unless I hear otherwise, or unless there's feedback on the list otherwise, this is going to be mandatory in MIME protocol, and we're going to keep going, keep cruising straight ahead. Okay. Next slide. Next, please. Okay, so what's left? So obviously we've got security review, we've got the cleanups, the issues that are mentioned. We have fixing the web bug. So we've got a proposed endpoint for downloading files, and that's PR number 75, and we have an attachments draft, which are they're sort of maybe 80% overlap. So we just need to sort of harmonize, come up with one solution, and do a proper security analysis of that, and then we can submit a PR. And that's that was sort of, let's say we had bigger fish to fry with anti-abuse, and I think that was people were more concerned about an existence proof for anti-abuse than for this, for which there have been several reasonable solutions in the industry. We have that third level of metadata privacy with pseudonyms, and so we have a draft from me and a draft from Conrad and Raphael. So there's a pseudonyms draft and the MIME draft. Our goal is that the MIME protocol, the base protocol, should be agnostic to adding these additional privacy measures. All right, two more big pieces. So we've got we need to define what some of this room policy is. So we've already outlined sort of the general shape of it, but I did write a standalone document, draft May MIME room policy, which will be discussed later today. And this has the new thing here is that this has the definition of roles and their capabilities. And then finally, we need to come up with a baseline identity mechanism and credential definitions. Saving the best for last. Okay. Do I have another slide? Yeah, okay, this just kind of, I've already talked about this. Next slide, please. Okay, and with this, unless there are any more questions on my presentation, I'm going to hand this over to Conrad.
Yeah, I just was wondering, I think we sort of vaguely know who is implementing this, but if there's new folks in the room who are implementing this, and if you could come to the microphone or into the camera, that would be useful to know, or type into the chat.
So we are going to implement probably all of the stuff that has been presented this morning, treating R&D, and I think there's more people in the room.
Okay.
You think there are, but they're not. They're
No one
not
is jumping up.
making those claims. Okay.
So
Thanks.
also, I would encourage folks, if you think, if you are implementing or thinking you're implementing, please please send a, if you feel uncomfortable saying this in public, please feel free to contact one of the chairs or one of the authors or editors or the area director. I know that there's somebody who's implementing Mimi content in the room. I don't know if there are plans also to implement Mimi protocol later.
That's okay.
Okay.
I'm not trying to like out people. It just, at some point it will be very helpful to get implementation feedback that feeds back into this process. So just wanted to check. Thanks.
Okay. Yeah. So we're left with the sort of the opposite problem of several working groups. We got some good specs, but we don't have enough implementations. So let's fix that. Thank you.
Okay, sorry, I was a bit confused if it was me or it was the discovery first, but okay, I guess I'll go ahead. It won't be long anyway. So yeah, Ron has already talked at length about what great steps we've taken towards getting more metadata privacy into Mimi. You've already heard we've got better metadata privacy on between the clients and the hub, so the followers are locked out a bit more. And now this continues to work a bit with regard to what the hub can see versus what the clients can see. Next slide, please. Yeah, so just a kind of brief list of the more juicy pieces of metadata that are visible to the hub. Concretely, the list of room participants, as Ron has already mentioned. Then the room can see the MLS group state, keeps track of that. That includes the membership list of the MLS clients, which will contain the credentials, although that's a bit still up for debate how that looks exactly. It's probably going to contain some sort of identifiers that will leak information. And then, of course, the hub can see the handshake messages and associate the handshake messages with the individual senders. And yeah, the question is, can we hide some of that metadata? Next slide, please. Yeah, so here's just a small example that I'll get back to in a second. You have the room state and you have the list of participants, Alice, Bob, and Charlie. And on the right side, there's the MLS tree kind of rotated 90 degrees for better reading. So we have client one of Alice, client one of Bob. Bob has a second client, and then there's Charlie. And that could be obviously more members in the room. Next slide, please. And so our proposal is to have this optional minimal metadata mode that rooms can run in, and that we're kind of simplifying slightly, but we replace the actual identifiers of the users and the clients in the hub with pseudonyms. And these pseudonyms are per room, so that each individual room has a different pseudonym per client per user, so that across rooms, the hub cannot see who's who. And so the way we do this to make sure that the other room participants or the other MLS clients in the room can still know who's in the room, so they can kind of pseudonymize the other participants. We have the actual identifiers encrypted in the credentials so that we still get visibility for the clients and solid authentication in the end. That, of course, means that the room participants need the key material to actually de-pseudonymize the other users. And that needs to be key material that the hub doesn't have. But luckily, we have MLS to distribute key material, so we get at least a big portion of that key management done for us essentially already because we use MLS. Next slide, please. Just to show you what this looks like, coming back to the previous example. So you have on the left side, you have the participant list, and the previously the names of the participants are now replaced by random strings of numbers or whatever the pseudonyms look like in the end. And then attached to them, you have kind of in these curly braces that denotes encryption. So we have the encrypted name Alice encrypted on the key K, and then Bob, and then Charlie. And so the hub only sees these ciphertexts because it doesn't hold the key K. And then similarly on the right side and the MLS group, you have the same pattern for the client identifier, which is now a pseudonym, and the user identifier, which is the same pseudonym as the, but on the participant list, this is kind of assuming that there's going to be this composed scheme that's present in the MLS credentials as well as in the participant list. And then there's the ciphertext, which are part of the credentials. Yes, next slide, please. So in true crypto fashion, we've turned problems into key management problems, in this case, privacy problems. And so, yeah, we have these nice properties, but of course, we now have more keys to manage. And so these are kind of a few requirements that we that follow from this. So first of all, users generally need to share key material among one another. So Alice and Bob, if you have users Alice and Bob, and Alice wants to add Bob to a group, that means Alice first needs to share some key material from Bob so that Alice can actually put Bob into a group under a pseudonym and then share the respective key needed to de-pseudonymize with the rest of the group so that all other group members in that group can learn that actually Bob joined and not some random pseudonym. Then similarly, and I mean, that's essentially what I said. So the adder needs to provide the keys to allow, oh no, sorry, this is a different point. So if an adder adds someone else to a group, they also need to provide the key material to the other group members, and then also the key material required to de-pseudonymize the people in the group that they add the new person, and they also need to provide that key material to the new person joining the room. So there's going to need to be a bit more kind of keys flowing around. The more tricky thing is if a user wants to join a room and there's no user online to help them join the room. And in that case, the user cannot learn the key from anyone who's already in the group. And so in this join flow where the user kind of joins independently from anyone else, we need some sort of way to provide that key as part of the MIMI protocol. For example, if we have, and we've discussed the join link feature before, then the key material would need to be part of this join link, or the join link would need to give that person access somehow without involving the hub and without allowing the hub to learn the key. And finally, there's a bit more key management involved, and some flows become a bit more tricky, but it's all symmetric encryption, and the impact on performance is really quite minimal. Next slide, please. So yeah, the original kind of MIMI protocol, we lifted this proposal from the things that we use internally in our messaging system, and that messaging system has just gone through an audit and came out pretty good. So we're pretty confident that this is a solid approach. But it's, as Rowan said, or Raphael said, I think there's still some rough edges where the exact nature of the approach depends a bit on other parts of MIMI. For example, the identifiers in the credential system, which we are probably now at a point where we need to work on that and think more concretely on what that looks like. But also other features like the join links, that kind of stuff. Yeah, to get that fleshed out, we're currently working on a PR against the MIMI doc where we add sections or a section on how that works and how the individual MIMI flows are touched by this approach. Again, it's all optional. So as Ron said, the base protocol should be agnostic, and you should be able to flip a switch and then have this extra protection. I think that's all I have to say. Any comments? Otherwise, expect a PR to come out, and then we can probably discuss that on the list or in the next intro. Thanks.
Excuse me. Next in the agenda is content format. So, Rowan, if you want to take the mic again.
Right. And I just answered in the chat to John. I found the construction where the application data, which is the thing that is about to be encrypted by MLS, that is part of the construction of the client's franking tag, and then that franking tag is in the AAD of the private message, and so the hub that can't be tampered with by the local provider. So yeah, there's integrity provided there. All right, so Mimi content. Next slide, please. Okay, basically there are a bunch of issues, some of which I recently added. I went through all of these this morning and I added comments to anything where I felt there was new information necessary. So starting from the bottom, we have some very old issues about our CBOR encoding. So I think we have an answer for the bottom two. We're going to remove, we're not going to use tags on URIs because CBOR web tokens don't do this on, for example, issuers and audiences. Basically anywhere where the semantics are clear, we're not going to, where the semantics are always a URI, we're not going to tag it with a URI. You would tag it in a place where it would be ambiguous. Likewise for timestamp, unless Mimi protocol adds to the hub multiple ways of expressing timestamps at different levels of granularity, there's no reason for us to have a tag, to have CBOR time tags. At the moment, we just have milliseconds since the epoch. If we change that in some way, we can then represent that change by possibly with CBOR time tags. I'm going to skip over this double wrapped array because I don't think we don't have a concrete syntax, but I will make a proposal for that later. I did notice in the process of looking at self-deleting messages that what we have today in terms of expiration in the draft doesn't actually do what most implementations of self-deleting messages do. Most implementations of self-deleting messages expire a certain number of seconds, minutes, or days, or weeks, or whatever, after the message is received or first rendered to the user, not based on the sender time. So I could send a message to Sean that's self-deleting after 1 minute, send it to him, he could go get it a month later and read it, and he's still going to be able to read it, but only for 1 minute if his client renders it, respects that request. So I plan to add in expiration both a absolute and a relative option. We had some comments from okay, go ahead, Acker.
So I agree with the problem statement, but how would you imagine that would be conveyed to the user?
You mean how would the client render this to the user?
No, how would how would I as the sender or the configurer of the chat set those properties?
So today in WhatsApp, for example, there's a little stopwatch icon in the composition, and if you click or tap on it, it comes up and says how many seconds you want it to be.
Yes, but now you have two values, so I don't understand how those would be related to one slider.
I'm sorry, I don't follow you. What are the two values?
Well, you said absolute and relative, right? The reason for that is to produce different effects.
Right. So every, I believe every, every IM system that I've used that has a sort of an expiration feature is always using relative times relative to when the message is first rendered.
Mm-hmm.
So this would just be adding support to in the expiration to be able to say this is a relative expiration time relative to when the with that those same semantics relative to when
Okay,
it's first rendered.
maybe I misunderstood. I thought you were saying you were going to add two values, but you're going to add a flag that says this is relative or this is absolute.
Yes.
Okay. I mean, does anyone, if nobody does absolute, why not just do relative?
I will send a message to the list after this meeting and ask if anyone wants to keep absolute.
Right. I mean, frankly, like relative gives me the heebie-jeebies, but like, but if nobody's going to do it, then
yeah, there is. I mean, the use case, the example in the draft clearly is more relevant for an absolute expiration. And so if people want to go do something like that, they would want an absolute, but that doesn't mean that there's, a community clamoring for that feature either.
And you say it's typically the read time as opposed to the receipt
It's
time?
the render. Yeah. So it's basically once the message has been rendered, then it deletes itself after that amount of time. So I would be, if you still have a Wire account, I would be happy to send you some messages back and forth that have a.
Yeah, I'm just trying to figure out what we think the actual right semantics are here. Because like the consequence of that is that in a large group, it's entirely possible that things never get deleted, even though the receiver's client is active, right?
Yeah, I think that's well understood by the users of self-deleting messages in practice.
Okay, I'm not sure it's well understood to me, but okay.
Yeah.
Okay, thank you.
Okay, we got a comment from Timo about GitHub flavored Markdown, and I went through the list. Most of those seemed sensible. There was one comment about representation of emojis, and I dug down and found that Unicode is very, very explicit that emojis define a semantic and not a representation. So if you were misusing water pistol to look like a Glock, and then your vendor changed the representation to look more like a Nerf water pistol, tough, not our problem. I plan to integrate the rest of the feedback the rest of the suggestions he made, but if someone wants to comment on the issue, it's there, please do.
Hey,
okay.
Rowan, you had just coming back to the expiration. There's a question in the chat from Will Earp. How would you report abuse on a self-deleting message? Is the metadata retained so it can be verified when reported? And he says the message content could easily be lost also. So can you talk a little bit about the interaction between abuse reporting and disappearing messages?
If the client wants to report a self-deleting message, they can still do that. There's no reason why you couldn't, because as long as the client still retains the frank and the plain text of the message and the franking context, it can still send a report.
But I think the question is more about the implications of that for, well, I don't know. I guess the question is ambiguous, but you can't report after the message has disappeared.
The user interface might not allow you to do so, but the hub has no way of knowing when the message disappeared. So if the client has a 1 week expiration and someone immediately reports abuse, the hub is not the police with respect to self-deleting messages, because self-deleting messages are entirely a client self-enforced feature.
Okay.
Okay, moving up to number 24. So I believe this was also Timo who said, yeah, maybe we should allow, currently the security consideration says that you're not allowed to edit or delete a message if you weren't the sender of that message, which seemed eminently reasonable until Timo pointed out that maybe you would like the ability in large groups for a moderator to say delete a message or to edit a message, for maybe to remove some nasty comments. So I can, unless someone has a strong objection, I can add a few paragraphs of security considerations to that, and I can add also appropriate capabilities that can be used in room policy to make that safe to do. Similarly, but maybe a little bit more, maybe a bit more of an issue with respect to how hard this would be for a client to implement. We have topic ID. And so I also got a request that someone would be able to edit a message to change, to say add or change the topic ID. So let's say that there was a, this might be implemented in, say, like something like Slack threading. So I start talking about something, and then someone later realizes, like, yeah, this really should be moved into a thread. And so, you know, maybe a handful of messages which were all about the same topic end up getting edited to add a topic ID, so these things become part of a thread. Again, I think I don't think we want to be too prescriptive here. I can add some security considerations around this and some additional comments inside of the place where topic ID is introduced to discuss this. I've got a note to add additional discussion on semantics regarding message delivery. So not all of the message delivery statuses are relevant in every case. For example, there is an expired, and whether you want to report that a message is expired or not. In some circumstances, I can imagine that you might want to say that. In some circumstances, you might not want to say that. Okay, finally, last scene. So I mentioned in Mimi protocol that oh, sorry, Jonathan, did you want to talk about one of those other issues? If so, please go ahead.
Sorry, I dumped this in the chat. I was wondering how, I just haven't had a chance to think this through. How does message franking interact with editing messages? Like, sorry, if the message is edited by some admin, how does that interact with the franking?
So franking is for a specific message, which covers that, you know, basically that message ID effectively. So if I have a message and then that message is reported, that message could later be edited or it could be deleted. So if you have the original message, you could report the original message. You probably wouldn't report the deleted message. And
so let's say it's the other way. Let's say I send, you know, good morning, and then the admin modifies it to say something terrible. And then exactly, and like, how is that then?
Then the message which is reported is the edited message.
But it still appears to come from me, or it appears to come from the admin?
It comes from whoever sent the message which makes the edit. So if the moderator modifies it to say, you know, like Jonathan is a poo-poo head, then you report the message that was sent by the moderator.
We have a code.
Okay, makes sense. Thank you.
That was an example. I don't believe that Jonathan is a poo-poo head.
Of course.
Yeah, but I would say works as intended. This is exactly why you need integrity over the message that I was mentioning
Yes.
earlier, right? Because you can report the message, but the integrity will not reflect the thing we can't say due to our code of contact being a part of it, right? And I mean, that does raise a further question of whether there should be some kind of franking for the editing or whatever, but like, does that?
Well, the edited message is a message. So the edit message is a message which has a frank on it.
Yeah.
And so the message which is being reported is the message that edits the original message.
Works as intended.
Exactly. Okay, so Will.
Will Earp. If you need to be able to verify what the message was when you report it for abuse, the actual content of the message, if it's already been deleted, how is the user going to be able to send the content of the message back?
You mean for a self-deleted message?
Yeah.
So if the user's, I mean, obviously, if the user's client pops a message up and at render time starts a counter, and that counter is 5 seconds and you don't quite get to it, that was your client, your client did that. You can go complain to your client vendor that it shouldn't allow self-deleting messages of less than 15 seconds or whatever, but if you click the button and start the process of reporting, your client, like a correctly implemented client, I imagine, should stop the timer and not go delete that message while you're in the process of filling out the form to report abuse on that particular message. And then once you send the message, you've sent the unencrypted content of that message to the hub. Your client might still go ahead and delete the message, but it's been sent to the hub, so it's out there.
So it's potentially down to a client to maybe have a minimum message time,
or maybe if you didn't see it, maybe you don't care. Maybe you really, it's only somebody who actually read the message that wants to report it. It's kind of it's a client implementation issue, but I don't think it affects either the protocol or the content format itself. We're just conveying a bunch of really intentions to the other side. We're conveying semantics.
Thank you.
Okay, last issue. Last scene. So we had previously we did not have it wasn't mandatory for the client to receive the hub accepted time. So we added this last scene mechanism, which is basically a partial directed acyclic group, right? And it suffers from problems that it's not even it's not even necessarily a full graph, because I could join the group and then I don't have any information from before, or I could have restored a backup and I have some messages here, and then I have a gap, and then I have messages that I've received in the same group. So I looked at the cases for what happens if we have both the hub accepted time and last seen. So I could have an honest hub. I could have, well, first of all, I'll mention that we have, if the follower modifies this under the franking scheme, if the follower modifies the hub accepted time, the message is going to be rejected by the receiver. So we really only are concerned about sender being honest or malicious and the hub being honest or malicious. If both are honest, then we could use the hub accepted time. That's totally fine. If both are malicious, well, we can't really do anything good there either, right? So the interesting cases are when either the sender is malicious and the hub is honest, or the sender is honest and the hub is malicious. As it turns out, there's really only one use case that we care about, which is when we have a last seen for a message, and the hub accepted time is earlier than what you would have expected from where it appears in the sequence with last seen. There is no way for the client to detect whether the client was malicious or the hub was malicious. So there is, someone who, feel free to identify yourself if you feel like it, pointed out that this is a fair amount of work to maintain some pretty imperfect information. And then it's not really clear what you would necessarily do with that information if you had it. If you had information that's something that, in this case, where you had a mismatch between hub accepted time and last seen. So this made sense, much more sense when hub accepted time was not mandatory, and this might be your only way of ordering messages. So the question is whether we still think that there's value in this mechanism. Anyone want to comment on this? And we can also take this to an interim as well, or on the list or in the issue in GitHub.
Yeah, I don't have a strong opinion on that right now, but you're probably right that we don't need it anymore. What I just want to say is that you should probably expect more feedback as people are starting to implement.
Oh yeah.
On that. So this is really, it's a very good starting point. There's going to be a lot more of exactly this kind of issues going forward.
Bring it on. Come on. I want to feel the pain. Come on. All right. Is there a next slide? I think I'm done. Oh, yeah. So I brought this up at one of the interims, but there is also, right now, the message ID is currently the hash of the ciphertext. But it means that if I have, if I then, I receive a message and I decrypt it, and then I say make a backup, and then someone restores it, or I share history or something like that, that message ID is no longer attached to the message content. It's just something to think about. I will post this in an issue. I think this is more food for thought than anything else, but I think this is something for us to keep in mind, just to make sure that we're keeping ourselves honest with respect to how important message IDs are in this protocol, because they're used. We reference message IDs all over the place. We should be able to make sure that the message IDs are reliable. Okay, one more slide, I think. Yeah, so please implement, give me feedback. I hope we have another Mimi interim soon, and I plan to make another version with a bunch of these changes that I discussed here in time for that interim. Thank you very much.
Okay, so one more Rowan deck, I believe, and then afterward we'll move on to discovery.
Rowan show.
Hi. Okay, next slide, please. I'm going to talk about room policy. Okay, what is room policy? Well, it's a bunch of information about access controls for a room, properties of a room. So for example, I came up with this concept of membership style. So I might have, for example, an open style room. I might have a members only room. I might have something which has a fixed membership. There are a bunch of descriptions in this draft that talk about that. The most important new thing in this draft is I extensively came up with a description of how we could have a list of capabilities and a definition of roles, where each role has a list of capabilities. There's a bunch of other stuff in here. I'm happy to talk about any of those other things, but I think the important thing is how you define roles, because they have a direct impact on the authorization of things in Mimi. Not all of these things are things which can be enforced by the hub. Some of them have to be enforced by clients. Next slide, please. So what kind of capabilities might you have? You can have a lot of capabilities. And if anyone has ever gone and configured permissions in Discord, you know that they can be incredibly granular, and there are lots of them. But the moderators love them. They're very, very popular. Just because under the covers we have a bunch of different attributes doesn't mean that on instant messaging user interface needs to expose all of this. It could be as simple as providing here I have administered groups and non-administered groups, and then, or I have I have this kind of like strong administered moderated group, and I have another one that's like a kind of a loose cooperative administered group. But let me just talk a little bit about the categories. So we've got things related to the membership. So that is probably what most people are, what comes to mind most when they think about, for example, an admin is I can add and remove people. But maybe in a cooperative room, maybe I'm allowing people to add their friends. So different roles in different types of rooms may have more or fewer or more of these capabilities for membership. We also have more explicitly moderator kind of capabilities, like being able to ban someone, being able to prevent them from sending messages, changing roles. Then we have things related to sending and receiving messages. So whether a user can send messages, whether they can report abuse, whether they can react, edit, delete. So this is where we start to get into features which have to be enforced by clients. So if I have somebody who can send a message, but they can't edit and they can't delete, that's something that has to be enforced by the client, because the hub doesn't know whether the message was a regular message or an edit or even a message at all. It could have been a report about message delivery instead. So I encourage folks who are interested in clients to look at these lists and to propose, if they want to even send some semantics, some text about semantics, if they want to propose, splitting or joining some of these or making them more general or less general. I welcome this kind of feedback, but this is a well-trodden path in that I got this list from lists of other instant messaging services which have been doing this kind of granular access controls for nearly a decade now. So does anybody have any questions about things that you think you could or couldn't do with this? Ah, Timo.
Hello, Timo Kösters.
Nice to meet you. Hi.
Nice to meet you. I was wondering if all of these have to be Booleans or if some could be more granular, like, for example, one for rate limiting, asking users to only send one message every X seconds, where the X can be configured differently for different roles. Thank you.
Yeah, I don't know. That's a good question. I do know that, for example, for change user role, in my examples, I'll show how I did have some parameters associated with this. Okay, let's go to some examples. Next slide, please. Okay, so I gave 3 examples here. And there's a lot of text on these slides, so feel free to download the slides and peruse them, and then come talk to me at lunch or after the second session, whatever. So in a strict administrator policy, I might have a guest, an ordinary user, and a group admin. And in this case, I also have a super admin. So guests, they can send messages, they can receive messages, and they can remove themselves from the group, but that's it. We also have a banned role. Banned user can do nothing. Pretty logical. Then we have ordinary users. Now, not because there is any special everything guest can do plus concept inside of the data structure that I represented here, but just to make the list shorter on the slide, an ordinary user would be able to do the 3 things that a guest can do, plus these additional attributes. They can add their own client, they can change their own name, their own presence, their own mood, their own avatar. They can send an abuse report, they can send links, they can send images, they can send videos. Great, that sounds pretty normal. Meanwhile, a group admin could do all the things that a guest and an ordinary user could do, and those would be, still like listed in the data structure. Plus, they can, add participants, remove participants, banish, ban, unban, change the room name, change the room mood, subject, avatar, etc. And they can change the user role. But in this case, they can only change a user from an ordinary to a group admin, or from a group admin to an ordinary. So that's an example for Timo of how that kind of thing would work. And then I have destroying a room and creating a join link. So I think this hopefully gives like a little flavor of the kinds of things we could do here. Finally, I'm going to add that we had this thing called a role constraint. So in this case, we're going to say a change to the participation list can only be valid if there is at least one group admin in the list. Thibaut.
Hi, Thibaut Meunier, Cloudflare. One question I have is, so like this is like very like role based, and like my assumption is like if I want like only a specific permission, like only allow a specific permission to a user, this means I need to create a role and then like grant that role to this user. Is that correct?
Yeah. So if you wanted to make, like, for example, I could create a new role called Thibaut Meunier, and then I could add I could put the specific capabilities that you have in that role, and then I could modify your participation list so that it has the role Thibaut Meunier.
Okay, and the capability to create roles is out of this proposal. I mean, like in the permissions, at least like I've seen.
So I think I think in the document, I didn't update it on the slide, but in the document, I think there is a create and modify roles in the, and maybe even in the example, the super admin had this capability. But yeah, this is a straightforward thing to add.
Yeah,
for sure.
Good. Thank you.
Okay. Next slide, please. So this second example, this is a cooperative room policy. So here, ordinary users have the ability to add new users and to do things like change the room name, and to even be able to kick out somebody who's being, maybe they're like, maybe the cat landed on the keyboard and they're sending a bunch of messages. So they don't really want to ban the user. They're just going to kick them out, and they'll, the user realizes they take the cat off the keyboard, and then they go and rejoin, and everything's fine, right? And here, the group admin only has a couple of special things. They're the only thing that the group admin can do that a regular user can't do is banning a user, unbanning a user, and changing their role, and destroying the room. Next slide, please. Okay, finally, we have a moderated room policy. And so here we've got, we have the different role names. So here we've got a non-participant, a guest, an attendee, a speaker, and a moderator. So an attendee can just they can add their own client, they can change their own name, they can send a report, but they can't send any messages. They can receive messages and they can leave. The guest can only receive messages and leave. So the speaker is the one, the speaker is the role that has the ability to send messages, to change the room name, to send links, images, and videos. Meanwhile, the moderator, they're the ones that can add participants. They can accept, if we end up supporting knocks, they would be able to say, accept a knock, and modify roles and ban users. So hopefully this gives an idea of the kind of flexibility that this gives. The good news here is that this is not prescriptive on what clients present as a user interface or what policies the hubs allow. So if I have a particular hub, they might just say, yeah, here's our one policy, or here are, here's a menu of 5 policies, pick one, pick which one you want it to be. Or they might offer something that's very granular and you can make a bunch of changes. The clients don't need to be able to represent all of this, but they do need to be able to respect the policy that they receive. So there's not a bunch of UI work that needs to be done for a client to be able to participate in complex rooms, but they need to be able to say, I have a particular capability. This user has this role has these capabilities. The user wanted to do this thing. Is that covered by the capabilities that they have? So that makes at least a fairly straightforward set of operations. Okay, I think that's my last slide. Any questions about this? Raphael?
There's always one, right? So yeah, going forward, I think it would be a very good exercise to see how this maps to what a hub can actually enforce as well. So a hub can maybe not enforce all of it because the content can be end-to-end encrypted, but it can certainly enforce some of it.
Yeah. So in the draft, there is a list of which of these can be enforced by the hub and which cannot.
Okay. Yeah, I missed that part. The interesting part is even with the advanced metadata minimization, the hub can still do a lot, if not everything.
Yes.
Compared to the normal mode. Yeah.
Yeah, so the hub can prevent a lot of garbage, but not everything. Who's in queue? Who's next?
I think that's me. I mean, I think this is great work, but there's lots of lists, for example, capabilities, and invariably we're going to forget stuff. Stuff will come up later. So I think this is also a good point to start thinking about extensibility.
Yeah.
And I know you've done a lot of good work on extensibility in MLS. Have you thought about like capability negotiation stuff already, or?
Yeah, it gives me a bit of a headache, but yes, I have started thinking about it. Yeah.
Okay, so it's maybe for the next interim to discuss.
Yeah.
Cheers.
Okay, so I would like to ask the chairs, what should we do with this and the room in general? So obviously from a perspective of documents, this can remain in a separate document or this can get merged into another document, but I'm wondering whether this is something that we want to make part of a either a working group item or part of a working group item.
So we can definitely do a call for adoption. I don't have like a strong feeling about whether we want to roll it in to the other document or not. I don't know if anyone else has a strong feeling.
I have a slight preference for keeping it separate for the moment, just because the protocol document has gotten quite large. And this is also something where I think the clients, there's a fair amount of sort of client and UI developer that want to pay attention to this that may not need to sort of look at the protocol document so closely.
Yeah, just wanted to agree with Ron on both points. I think this is important to have. We need something like this, so let's go adopt it. And I also think because of the size consideration, it's like, again, lots of lists, and I think we should keep this separate.
Okay. We can issue the call for adoption to the list, give people time to review.
Okay. Do you want to do a poll or just only on the list?
Oh, we can ask in the room, I guess. Let's see. It's still early in the morning. Where is my show of hands?
That's why I asked for 20 minutes instead of
Okay, I put the poll up.
Nailed it.
Okay.
There's 62 registered participants of this meeting. You could stand to see more than 15 votes, please.
Well, I mean, not everyone has read it probably, so it's okay if you don't. You can put no opinion. Okay, you have 10 seconds and then we're going to close the poll. Okay, so we had 16 in favor and 8 no opinion and nobody opposing. So I think we have a good show of support for adopting this document. We will confirm it on the list, but unless we get significant objections, we will adopt this document. Thank you, Rowan. And now we're going to move on to, we're going to start discovery and then we'll pick it up again after lunch.
Okay. User discovery. So hopefully we'll use the rest of the time to cover that, like Alyssa said, and we'll pick it up later this afternoon because there's a lot to cover. Next slide.
I don't think it's wired up. So you just have to ask. Next slide.
So what is the user discovery problem about? It allows me to find out what messaging service I could use to contact you just by knowing your telephone number or your email address. I might not know whether you're on Telegram or WhatsApp or whatever, but I can do discovery to learn that fact. So this draft is about the requirement for discovery using 2 identifiers. First, the user telephone number and email address, because these are globally unique identifiers. Next slide. So here is the terminology we've kind of settled on for discovery. So I'll take my time going through it in case there are people that is seeing this for the very first time. So the first one is cross-service identifier. This is an identifier that is globally unique to you, like your phone number or email address. No other person has that. Just call my phone number from anywhere in the world, you can reach me. That is cross-service identifier. You can use it across multiple messaging services. So these identifiers are typically issued by a cross-service identifier provider, like your telephone company or your email address provider. They issue you that identifier. That is important for discovery because in the case of telephone number, someone might lose a number and the number get reassigned to a different user. So how do we deal with discovery problem after that phone number is reassigned? So that will be covered later. Of course, the third terminology is your messaging service provider. We are pretty much familiar with that, like your WhatsApp and so on. We also have an identifier that is in the context of an MSP or a messaging service provider. That is the service-specific identifier. And last but not the least, there is a new entity that is not yet available that will play the role of collecting what we call mappings and helping user learn the fact about what messaging service a different user could be reached on. So that it will be the role of the discovery provider. Throughout the discovery session, we're going to be using a lot of this acronym. I'm spending a lot more time than necessary just to give everyone a little bit more familiarity with them. When you see CISP, you kind of know what I'm referring to. Next slide, please. So again, two main aspects of the discovery problem. Basically, we need to assert verifiable mapping from your telephone number to the messaging service on which you can be reached. Basically, creating an entries or a record for a database that will aggregate that. And then the second part is doing the lookups over this requirement. And in the process of doing this, we want to prioritize privacy. And we also want to respect the preferences of the user that created the entry in the database by saying, this is my preference for how this mapping should be used to reach me. For example, my mapping might have WhatsApp and Telegram, and I might have a preference on when to reach me through WhatsApp and so on, as well as privacy integrate with other protocols. Next slide, please. So in Vancouver, we presented a long list of 23 requirements under these 5 broad categories. One about how those mappings are created, how the user that established the mapping express preferences, and how the discovery protocol requirement for the discovery protocol as well. We also provided some operational requirement as well as security and abuse prevention requirement. It's a long list of requirements, like I said. Next slide, please. This one is for the authenticating mapping requirement. As you can see, we have like 6 long requirements there. Next slide, please. I'm not going to go through this individually. Next slide. Next slide. That's the operational requirement. Next slide. And next slide. Okay, so that's a pretty long list of requirements. It's particularly challenging to come this low level, given that there's no predetermined architecture for how discovery to work. Should it just be a single server that you query? Should it be frustrated? What does it look like? We don't know that yet. So we are just creating requirements. So an adoption call was made for this, and some of the feedback we got, especially from Eric, is that that's a lot of requirement. Like we want the requirement to be a little bit more abstract, to be more high level, so that it won't constrain the protocol definition and future implementation of this. So we took note of that, and we kind of now went a lot more high level to come to 10 requirements that we believe kind of capture the essence of the discovery problem. Yeah, thanks a lot, Eric, for all your feedback offline to get to this next iteration of requirement. Next slide, please. Okay, so we group the requirement into 3 roles that we want to use to simplify things. So first one is the recipient. Second, the sender, and then the discovery provider. So the recipient is the person that you normally call. Like Rowan, I want to call Rowan. Rowan is the recipient, right? So for me to call Rowan, that means Rowan needs to establish a mapping that shows what messaging service I could use to contact him. So as a sender, I have a phone number for Rowan, and I want to discover which messaging service I could use in communicating him. I'm the one that will later on originate the communication to him. Then we have the role of the discovery provider. So there are these mappings by individual recipients that they've established. Then the role of the discovery provider will be to aggregate those verifiable mappings from different users, and also play the role of lookup. What is the CSI or the telephone number you are interested in looking up? I can return back to you the mapping of interest for that. So this is much more simplified, and that's what we've got. Next slide, please. Yeah.
Hey, hi, Rowan May. So I was just curious. So as an end user, I might have records in multiple CSIPs, and I might have different like the records that are in one CSIP might be different than the records that are in another CSIP.
Yeah. Okay. So so your CSIP is like your telephone company. That means you have different phone numbers. Essentially, that's what you mean. And then each phone number is independent. You can map. You can say I'm discoverable in this phone number, only in this messaging service provider, and this other phone number in a different or a similar set of provider. You can do that. Yeah.
But for one phone number, there's only one CSIP, or there could be
multiple. Oh,
there could be
multiple. Yeah.
Okay, and I could have a different set of records for the same phone number on this CSIP than this CSIP.
So CSIP is like your, CSIP is the issuer of your globally unique identifier. Yeah. Go ahead.
Yeah, John Peterson. So, I mean, any telephone number, there is a single entity, right, in the E164 system responsible for issuing it. Similarly, an email identifier, whoever is on the right-hand side, the host domain, say they issued that. You can have it in multiple CSPs. You can bring that CSI, that CSI to multiple MSPs.
Yeah. Thank you. Got it. Okay. Thanks. Thank John. John is a co-author for this. Next slide, please. Oh, there's more. Who has on the queue? Okay, Eric.
Yeah, I just want to clarify that just because the CSIP authorized the issuance of an identifier does not mean they're the mechanism by which the identifier is validated, however, correct?
John's giving you a thumbs up in the hall.
Yeah, go ahead, John. Yeah.
Yeah, I mean, obviously, the way the argument I've made is that there needs to be an independent way to have a binding between the MSP itself, like the consumer that's authorizing the use of the CSI, and potentially the CSIP, like depending on the circumstances, in which the identifier is being used. But at the very least, between like the MSP and the consumer that it has a proof of possession of the CSI.
Right. I guess just think about like domain names or telephone numbers. The canonical way to establish ownership of a domain name is not to ask is not to ask the registrar or the registry. It is to verify receipt of a message. Right.
Of course, but in the context of a CSIP, I think we would consider, for example, Google to be the CSIP for your Gmail address, right? Like, and you would use a proof of possession to your Gmail address to ascertain the binding in that instance.
And who's the CSIP for? And the CSIP for you're saying the CSIP for my phone number is T-Mobile, for instance.
Yeah. And then your CSIP for your Gmail address is Gmail, right?
Right. I guess the thing I would say is that the CSIP does not generate any attestation. It does not generate any verifiable attestation of that. Right. Okay. Good.
Correct. Yeah, that has to be done. I've argued by effectively a third party that establishes the binding, but like that's separate question from this question. Anyway,
it's not a discovery problem. Yeah.
Thank you.
Okay. Next slide, please. Okay, now we get into the requirements. So for the recipient requirements, we have some preconditions. So first of all, is the user possesses a CISP that is issued by a provider. I have a telephone number issued by my telco company, for example. And then the user has an active account with a messaging service provider. And also the user has taken the step of associating that CSI to that account. So these are non-discovery problem. These are preconditions for discovery. Any question? Okay, next slide, please. Now we get into the requirement. So for the recipient, we have three main requirements. So the first one, we're going to be going like very, very slowly. It just a slide with 3 points on this, but we'll go very slowly so that we can ensure that this is broad enough and any question anyone asks is kind of answered. So for the first one, we're saying any mapping of your CSI to MSP must only be verifiably authorized by the recipient. That means you are the holder of the CSI, only you can authorize a verifiable mapping for that CSI. Does that sound good? Somebody should not try to impersonate you and create a verifiable mapping for your CSI. No, only the holder of that CSI should be able to do that. That's pretty high level. Eric?
Yeah, so we had some back and forth about this over email, but I think probably like one thing I want to call attention to is this does not provide a mapping from the CSI to, forgive me, I've forgotten the name of the thing you call local identifier in MSP, the specific identifier, and so it only creates a mapping from the CSI to the MSP. So, for instance, if you bind my phone number to WhatsApp, WhatsApp is free to reassign that to any human it pleases. So the level of security provided here is relatively modest, and I think that's not necessarily. I think this is something I'm not sure we ever explicitly decided, and maybe it's the right answer, maybe it's not. But I wanted to make sure like we all discussed it before, like we just sort of wrote it down here.
Yeah, SSI is not in scope for this. We are just saying the CSI only. Okay, thanks. Next,
Alyssa, go ahead.
I want to discuss it. I want to.
So just to be crystal clear, number one here is about the mapping of a recipient's CSI specifically.
That's correct.
Okay. I think it would be good to just always modify that so that it's clear. I know that that's the whole set of requirements that you're talking about right now, but the recipient CSI has to be verifiable only by the recipient.
Yes. We did mention recipient as your last word. Are you saying it should be earlier?
No, I'm saying that we're talking about the CSI of the recipient. Because otherwise it's like ambiguous.
Okay, thank you.
Yeah, that's all.
Yeah.
Yeah, it is. I kind of prefer like potential recipient or prospective recipient, or like, I mean, because this is a forward routing, mapping that we're establishing in this instance. But I was actually coming up to say, let's pick this up after lunch. I agree, Ecker. We want to discuss it. We have 1 minute left before lunch. Let's go to lunch and come back, and we'll dig into this. I think it works, but like, let's dig in.
Yep.
Yeah. Okay. Well, thank you for doing the setup before lunch, and we'll see people after lunch.
Yeah. Thank you. See you after lunch.
Thanks.
Thanks.